Hello, I'm Matthew, and today we'll study how to use the sine law to find the missing angles and the sides of a triangle. Let me briefly talk about the sine law before using it to solve a problem. First, sine law is useful for all types of triangles and not just the right triangles. Second, sine law is useful for finding both the angles and the sides. Pythagorean theorem, for example, can only be used for right triangles and it cannot be used to find angles, but sine law can do it all, meaning it can be used for all types of triangles and find both angles and sides. However, there is a condition for using this law, and that is you always need a set of an angle and its opposite side. If you look at the triangle on the left, you can see that the side is labeled according to the angles that it is the opposite of. For example, opposite side of the angle A is labeled as side A, and opposite side of the angle B is labeled as B, and opposite side of the angle C is labeled as the side C. And you always need these sets, either the angle A and the side A, or the angle B and the side B, or the angle C and the side C. And the equation for sine law is this. Sine of the angle A over the side A is equal to the side of the angle B over B is also equal to sine of angle C over the side C. I'll show you how to use this law as I solve the next question. Find all missing angles and side. Okay, let's first see what we have. We have the angle 42 and the side 15 and the side 12. Oh, look, we have a set. The opposite side of the angle 42 is the side 15, and that means we can use the sine law. So let's start. Sine of angle 42 over 15 is equal to, let's use the side 12 to find the angle E that it is the opposite of. So we have sine E over 12. Let's cross multiply. 12 times sine 42 degree is equal to 15 times sine E. What can we do to isolate our variable E? We can divide both sides by 15 to cancel this out. Then we have sine E, I'm going to write that first, is equal to 12 times sine of 42 degrees over 15. We just have to do one more, and that is the opposite operation of sine. And what is that? It is the inverse sine. Inverse sine and sine cancel each other out, so we just have E. And on the right side, we have sine inverse, that is inverse sine, of 12 times sine of 42 degree angle over 15. And if you plug this into your calculator, you will see that we have 32.36. Remember, the question asked to round to 2 decimal places. So that's 32.36 degrees. And that's the angle E. Because we know two interior angles of a triangle, we can find the third one, angle F, by subtracting two angles from 180 degrees. So angle F is equal to 180 minus 42 minus 32.36. And that is equal to 105.64. It's now time to find our last side F using the sine law. We can still use our initial set, sine of 42 degree angle over 15. That is equal to, you see how side F is the opposite of the angle F. So we have sine, what's the angle F? 105.64 degrees over F. Let's cross multiply. Then we have side F times sine 42 degrees is equal to 15 times sine 105.64 degrees. What can we do to isolate our variable F? We can divide both sides by sine a 42 degree angle so that we can cancel these out. Then we have f is equal to 15 times sine of 105.64 degrees over sine of 42 degrees. And if you plug this into your calculator, you'll find that f is equal to 21.59. And we can write that here, 21.59. And this is how you can use the sine law to find the missing angle and the sides. I hope that you found this video helpful. If you did, please hit the like button and subscribe. I'm Matthew, and I'll see you in the next video. Bye!